Now dear student, we are going to discuss question number 3.16, and in this question it is given to you, look at the graph from figure A to D carefully and state region which of the following cannot possibly represent one dimensional motion of a particle. Clear? So my dear student, we are going to analyze each and every graph and let us try to understand which graph is possible or which one is not. Clear? So now concentrate on a screen. Now in the situation number A, it is given to you, let's suppose this is a graph that is given. Let's suppose if I draw here a perpendicular that is parallel to x-axis like this. Listen carefully what I want to say. You can see at a particular time, let's suppose this time is t. So at a particular time we are getting here two positions of a particle, this one and this one. I think you are getting my point, yes or no? So at a particular time we are getting two positions of a particle, that is not possible. It means, let's suppose if I say to you, you are present at this time, you are attending this lecture, yes, and you are also eating some food that is somewhere else. This is not possible because whenever we have a one particle at the same time, a particle cannot be present at two positions. Clear? So it means we can say this does not represent motion in a straight line. Yes or no? So this graph will not represent one dimensional motion. Clear? Now if we move to the graph number B, in this graph we can say, let's suppose again if I draw a perpendicular, this is parallel to this velocity axis. We can see at a particular time, we are actually getting here two velocities. Clear? One velocity is positive, here we are getting positive velocity, and this one is negative velocity. It means what I want to say, let's suppose I am saying to you at time t equal to 2 seconds, particle is moving in positive x direction, particle is also moving in negative x direction. This is not possible. Yes or no? Because at a particular time the particle will always move in a particular direction. Clear? It means we can say this is also not possible. Clear to you? Yes or no? Yes. Now if we consider graph number C, in this graph is given to you between speed and a time, and now you can observe here it is also given the speed is also negative. Now speed is what? It is distance covered by the time per unit time, distance covered per unit time. So when we know for a particle is in motion, distance is always positive. It means we always find speed is positive. It means negative speed is not possible. It means we can say this is not a graph that is representing one dimensional motion. Clear? Now if we consider part number D, here it is given total path length versus time. Clear? So now you can see whenever a particle is having one dimensional motion, it is given total path length. It means this is distance, total distance covered. Clear? Now we know whenever particle is in motion, distance is always added. Let's suppose at time t equal to 0 I am here. When I am moving like this, it means let's suppose I covered distance 1 centimeter or 1 meter. Clear? Let's suppose after some time I again covered here some distance. It means now distance is always added. Yes or no? It means we can say from this graph you can see with time the distance is increasing. Yes, that is correct. But here we can say with time distance is decreasing. So this is also not possible. Yes, if this graph represents displacement, it may be possible. Clear? But for the distance this is not possible. So we can say from A, B, C, D all are not possible with reference to one dimensional motion. Clear to everyone?